So suppose you want to calculate the area of a disk, but you don't know the formula or it hasn't been discovered yet. But let's say you do know the formula for its circumference. So I'm going to show you a clever trick. The way I'm going to do it is by dividing the circle into smaller pieces and rearranging those pieces into a shape that we do know how to calculate the area of. And that shape is a parallelogram, whose area is given by multiplying the base by the height. So to start off, I traced a circle and now I'm going to cut it into slices. For the purpose of this video, let's say this is a pizza, and the thick black line, which is the circumference of the circle, is the pizza crust. So now I'm arranging my pizza slices to form a parallelogram, just like I said I would. So you can see it's not perfect, but it's a decent approximation. Almost happy with this. Now the question is, can we do better? Sure, by cutting the pizza into smaller slices, we reduce the bulge in the crust of each slice. Let me demonstrate. So here I have a pizza with 16 slices instead of 8. As you can see, each crust is a little bit less rounded. So when I arrange these to form a parallelogram, we get a closer approximation to the real shape. Can we do better than this? Yes, with 32 slices. Look at how much less roundness each slice has. And for us, less roundness means less error. And we can keep taking pizzas with more and more slices until in the limiting case we have a pizza with infinite slices, which is an essentially perfect approximation. But anyways, before cutting up this pizza, I want you to notice something about the angles. Notice that the more slices we have in a given pizza, the smaller the central angle of each one. When I arrange them from biggest slice to smallest slice, it's quite clear that the smaller the central angle, the less roundness we notice on the crust. And the less roundness means better approximation to the straight base of the parallelogram. If you're still not convinced, recall this formula from calculus class, which supports my point. Sine theta over theta goes to 1 is the same as saying sine theta goes to theta, where theta is the arc length tended by the angle, aka the pizza crust, and sine is the projection of the angle onto the y-axis. Did I lose you yet? No worries, I'm about to show you how this is all going to work out. So I just need to remind you of one thing first. See, I have all my pizza slices here, which were all once part of the same pizza, which means that the sum of all their crust is equal to the circumference of the circle, which is 2 pi r, which means if I arrange them such that half the crusts contribute to the bottom edge and half the crusts contribute to the top edge, then each edge is exactly half of 2 pi r, which is pi r. And the height? Well, that's just the distance from the center to the edge of a pizza slice, which is r. And recall the area of a parallelogram is just base times height, which is pi r r, which is pi r squared.